Hi folks, so exo and endothermic energy changes. You've come across these before at Key Stage 3, we studied them in Year 9, and you are all familiar with reactions like burning a piece of coal, which feel hot. If you put your hands near a burning bit of coal, it will feel hot. It's an exothermic reaction. Exo meaning that heat is exiting. You've also probably less familiar, but still familiar with endothermic reactions. These are ones that will feel cold. So if you've ever had an injury in the sports field and been given a sports pack, you would have experienced an endothermic reaction with the ice pack feeling cold. You can think of that as into instead of endo, just for helping you to remember which one's which. So exits, exothermic, the heat exits, endothermic, energy is transferred into the reaction mixture. So if we think about what would actually be happening in a test tube reaction, we'd have a reaction mixture in here, we've just mixed things together, the reaction started, and the test tube would start to feel hot in an exothermic reaction. Energy would be transferred from the reaction mixture outwards to the surroundings, and the temperature on the thermometer would go up. If we did an endothermic reaction in a test tube, the test tube would actually feel cold to touch. We would see the temperature drop down, and energy would be coming from the surroundings into the reaction mixture. Now, that's something that sometimes confuses people, because when you say that energy has been transferred from the surroundings into the mixture, you kind of think, well, shouldn't the temperature go up then? But of course, the energy coming in is not being used to raise the temperature. The energy coming in is being used in the reaction to make the reaction happen. Okay, so let's have a closer look at what's actually happening in terms of bonds breaking and bonds forming and the energy changes. So here we've got a reaction between nitrogen and hydrogen. They're both reacting together to make ammonia. Now, for that reaction to happen, all of the bonds in the reactants need to be broken. So this bond here, broken, 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 broken. That takes energy. To break the bonds, you have to put energy in. So let's say for us to break all of those bonds, it takes 100 joules of energy. When the reaction is taking place, new bonds are forming to make the products. So all of these bonds here have to be formed, and this releases energy. So releases energy, and in an exothermic reaction, what we would have is it taking less energy to break the bonds than is released when the new bonds are made. So let's say we get 200 joules of energy released this time. So overall, we only had to put 100 in, but 200 joules has come out. So overall, there's a change of minus 100 joules. It's an exothermic reaction. More energy was released to the surroundings than was taken in to break the bonds in the first place. If it happened to be an endothermic reaction, which it isn't in this case, but let's just imagine it is, let's say we still put in 100 joules of energy to break all the bonds this time. But when the new bonds were formed, it only released 50 joules of energy. Therefore, we've got a plus 50, and it would be an endothermic reaction. So I hope that helps you understand the difference between the two. Key things to remember: bond breaking is exothermic, bond making is endothermic. A way to remember that: bendo, mexo. Breaking bonds is endothermic, you put energy in. Making bonds is exothermic, energy gets released. If it was exactly the same amount of energy to break the bonds as it is to make the new bonds, you wouldn't detect an energy change, the thermometer wouldn't change.